All right, let's do practice problems for left-hand and right-hand sum Riemann sums. For the function graphed on the right here, I want you to draw the rectangles forming the left-hand sum and shade it in blue, and then calculate the left-hand sum where they let delta t equals 2. When they say delta t equals 2, that means the width of each rectangle will be 2. So I have 3 rectangles here. So your job is to interpret that delta t equals 2 on an interval from 0 to 6 means that I need 3 rectangles. So I'm going to hit pause and draw in my rectangles, and I'd like you to do the same. Okay, I've got my 3 rectangles drawn in, and now I want to come up with the area that they represent. So I have a base of 2 and a height of 8 for the first rectangle. For the second rectangle, I have a base of 2 and a height of 7. And for the third rectangle, I again have a base of 2, and this time I have a height of 5. So when I add all this up, I have 16 plus 14 plus 10, which gives me 40. And I don't have any units here, so I just leave it as 40. So now on the same graph, I'm going to draw the right-hand sum and shade it in red. So I'll hit pause and I'll do that, and you do the same, please. Okay, I've drawn my right-hand sum in red, and now I'm going to find the area of the right-hand rectangles. So again, I have a base of 2 times each of these. So I'm going to set this one up a bit differently so you can see a different setup. Since I have the same base of each rectangle, I'm essentially going to factor out that base and just add the right-hand heights of each rectangle. So I have the height of the first rectangle of 7, second rectangle has a height of 5, the third rectangle has a height of 2. And that gives me 14 times 2, or 28. So the next question that we're asking here is which underestimates and which overestimates between the left and the right-hand sum? Well, the right-hand sum in blue contains these regions here that are actually above the curve, and I'm shading them in green. So the right-hand sum, excuse me, this is the left-hand sum. In blue is the left-hand sum, has these regions that are above the curve and should not be included in our area. So in this case, the left-hand sum is an overestimate. Now, separately, the right-hand sum, which I'm going to change colors and do in purple, actually misses some regions here that should be included in the area that are not included in my right-hand sum. So the right-hand sum in this case is an underestimate. So what we're going to do now is repeat the first 2 steps of drawing in blue rectangles and red rectangles. Blue is still going to be the left-hand sum, red is still going to be the right-hand sum, and we're going to do that on this curve here and then come up with the area represented by the blue left-hand rectangles and the red right-hand rectangles. So if you could pause and try this problem, and we'll come back in a minute. Okay, I drew in my left-hand sum in blue and my right-hand sum in red. So let's go ahead and calculate the area of the left-hand sum. This time they had given me a delta t of 0.5, so I'm going to factor out the 0.5 and then just add in the brackets the left-hand height of each rectangle. So the first rectangle has a height of 1, the second has a height of 4, and the third has a height of 6. So I'll add 1 plus 4 plus 6. So that is 11 times 1/2, or 5 1/2. So that is my left-hand sum. Now if I switch to red to find my right-hand sum, I once again have the the base of each rectangle is 0.5, so I'll factor that out in front. Then I'm going to add the right-hand heights of each rectangle, I'm going to add the heights of each of the right-hand sum rectangles. So I have a height of 4 for the first rectangle, then 6, then 7. So I'm adding up in the brackets 4 plus 6 plus 7. So if I pull that together, I have 10 plus 7 is 17 times 5 is 8.5. So the next question actually asks us to take a look at what we have from these 2 problems, this first problem and this second problem, and try to understand when the left-hand sum or the right-hand sum will underestimate versus overestimate. Because looking at this problem, the left-hand sum here is an underestimate because I've got sections that are under the curve but not contained within the left-hand sum. So in this case, we have an underestimate for the left-hand sum. The right-hand sum, of course, has sections that should not be included that are over and above the graph, so this one is an overestimate. So we've just shown where the left-hand sum overestimated the first graph but underestimated the second graph, whereas the right-hand sum did the reverse. It underestimated the first graph and overestimated the second graph. Well, do you notice that both of these graphs are concave down? So it cannot be concavity that's driving this. But what's different about these graphs is that the first graph is decreasing and the second graph is increasing. And the increasing or decreasing intervals are what give us the underestimate or overestimate information for left-hand sum. So on an increasing function, such as this second one here, the left-hand sum heights underestimate the area under the curve, and the right-hand sum will overestimate. And that makes sense because the right-hand heights are using the higher right side of each rectangle. Because the function was increasing, the right-hand side is higher each time. So now let's take a look at what happens with a decreasing function, which is like the first one that we saw on this page. In a decreasing function, the left-hand heights are actually the higher heights since the y values are decreasing throughout. So the left-hand sum, the left-hand Riemann sum, will overestimate, whereas the right-hand Riemann sum will underestimate.